Today I'm going to show you how to do particles to grams and grams to particles. Particles can be atoms, molecules, formula units. It doesn't matter. It works the same no matter which type of thing it is. So here's the problem that we're going to work. We are going to convert 4.78 times 10 to the 24th atoms of carbon to grams of carbon. And so we always start with what we're given. 4.78 times 10 to the 24th atoms. And it doesn't matter atoms of what at this stage, because our first conversion factor, we're going to get it to moles. So although it doesn't give you moles or ask for moles, moles are always in the problem. Don't forget that. You always have moles. So you have to go to moles, and then from moles we can go to grams. So since our top are given as atoms, whatever we're given, whatever unit, has to go on the bottom here in order to cancel. And we're going to moles. Well, 1 mole of anything is 6.022 times 10 to the 23rd atoms. And then our atoms will cancel and we'll be left with moles. But we're asked for grams, so we have to go one more step. We're going to take moles as on top, so we're going to put our 1 mole on the bottom. And we're going to go to our periodic table and find carbon as 12.01 grams per mole. So 12.01 grams of carbon in 1 mole of carbon. Our mole cancels, and we're always left with whatever unit's in the upper right-hand corner. So on top, we're going to have 4.78 times 10 to the 24th from here, times 1 times 12.01 grams. On the bottom, all the units have canceled, and all we're left with is 6.022 times 10 to the 23rd, Avogadro's number. Now, an easy way to work this is to go ahead and cancel your 10 to the 23rd with 23 of these, and that just leaves us 10 to the 1st up there. So we have 4.78 times 10 times 12.01, which is 574.078. We don't want to cut anything off or round anything yet, not till the end. And on the bottom, we canceled our 10 to the 23rd, so we just have 6.022. So in our calculator, we're going to put this number divided by 6.022, which leaves us with 95.3301, etc. And so what we're going to do is we are going to take this number. We're going to look back at our original. We had 1, 2, 3 sig figs. So we're going to keep 3, and we'll have 95.3 grams of carbon as our final answer. Let's do one more in this direction, and then we'll try one in the opposite direction, going grams to particles. Let's convert 7.78 times 10 to the 25th molecules of CH4, which is methane, to grams. So we're trying to find the number of grams. Again, it doesn't give you moles or ask for moles, but moles are in the problem. So we're going to start with our given. I'm going to use MC for molecules. That is not a real shorthand, but it makes it a lot shorter to write. And we need to cancel molecules and go to moles. Well, 1 mole of anything is Avogadro's number, 6.022 times 10 to the 23rd molecules. Notice it worked for atoms, it works for molecules, works for formula units, which are the same as molecules except held together with ionic bonds. So this is going to cancel molecules, and this is giving us moles of CH4. Notice the mole's always 1 here. So now we need to convert from moles to grams. So since moles is on top, we need to put moles on the bottom. Again, it's just 1 mole CH4, and we have to figure out how many grams that is by adding it up off the periodic table. So carbon was, as we saw before, 12.01 plus, we have 4 hydrogens. Hydrogen is 1.01, which gives us 16.05 grams per mole. Again, we can cancel our 10 to the 23rd with 23 of these. That leaves us 10 squared, or 100, on top there. So we're going to have 7.78 times 100 times 1, which we don't need, times 16.05. Our moles have canceled. We're left with just grams. And on bottom, we just have 6.022 times 1. So we are going to have 7.78 times 100 times 16.05 divided by 6.022, and we get 2073.54, etc. And we go back to our original. We had 3 sig fig, so we're going to keep 3. So it's going to be 2070 grams CH4. That has 3 significant digits. We need this 0 to keep our distance to the decimal point, and that's our final answer there. Let's do one more, going grams to particles. So here's our problem. This time we're asked for atoms. Remember, particles can be atoms, can be molecules, can be formula units, can be any of those 3. So how many atoms as particles, so that's what we're asked to find, of copper are in a sample with mass 12.70 grams. That's a U right there, copper. All right, kind of looks like an A, which would be calcium, which would throw us off. All right, so we're given grams this time. So again, you start with what you're given. We're given grams. So we have 12.70 grams of copper. And we want to convert that to moles, of course, always to moles. So we have grams on top, so we're going to put grams of copper on the bottom, and we're going to put 1 mole on top. And 1 mole of copper is equal to 63.55 grams. Then that will cancel grams, and we will have moles, but we're asked for atoms. We need one more step, and 1 mole of anything is 6.022 times 10 to the 23rd of those things. In this case, atoms. So we're going to have 12.70 times 1 times 6.022 times 10 to the 23rd. And on the bottom, we have 63.55. All of our units canceled except for atoms, so we're left with atoms on top as our only unit. So I'm going to leave out the 10 to the 23rd to start with. So I'm going to do 12.7 times 6.022 divided by 63.55, which gives us 1.203, etc. But we can't forget our times 10 to the 23rd atoms. And then we go back, we have 1, 2, 3, 4 significant digits. Remember, a 0 to the right of the decimal, at the furthest to the right, is still significant. So 1, 2, 3, 4. So our final answer will be 1.203 times 10 to the 23rd atoms of copper. And that's how you work them in that direction. I hope this has helped. If you have questions about how to figure out significant figures, or to convert grams to moles or moles to grams, just that single step, I have videos on all of that. So please check them out.